Hi, this is Dr. Green. We're looking at WebAssign Homework 6, problem number 28. So this is a similar example. We're looking at a two-way ANOVA, and it's for gender and political ideology or party. So we took a group of men and women from the three main political parties, and we surveyed them on their positions on different issues, and they completed a Likert scale, with 1 being most conservative and 10 being most liberal. And then they gave us a partial F table here, and they want us to complete the F table and then make the decisions to retain or reject the null. So, well, in this sum of squares column, everything has to add up to 378 here. They've only left out one number, so that number there has to be the total, 378, and then subtract these other three numbers. So minus 12 plus 84 plus the 240. And that leaves 42. So this is a 42. Degrees of freedom, looking at the general structure for an ANOVA down here, and I got this from the exam 2 formula sheet. So P is the number of levels for factor 1, which is gender. So P equals 2 minus 1 is 1. Q is the number of factors for political party. 3 parties minus 1 is 2. And then the interaction, you just multiply these two values. So 1 times 2 here is equal to 2. And then sum these up to get the total, because this is total row. That's 45. And then you get the mean square, this column here, by dividing sum of squares by degrees of freedom. So you take the first column, divide by the second to get the third. So 12 divided by 1 is equal to 12. 42 divided by 2, 21. 84 divided by 2, 42. 240 divided by 40 is 6. And then you get your F statistics by taking the mean square column, divide by mean square error. So mean square for that factor. So for the gender factor, our mean square is 12. The mean square for error is 6. So we do 12 divided by 6, which is 2. And then 21 divided by 6 is 3.5. And then 42 divided by 6 is 7. So now we got to test all these to see if they're significant. And remember that it's significant if you're going to reject H0, which means it's significant if your test statistic is greater than your critical value F alpha. So that's the table value on page 661 in the text, where you use degrees of freedom numerator and denominator. So this 2 here, and we need to test that. And we need to ask, is that 2, which is our test statistic, is that greater than the critical value, f.05? And then our degrees of freedom are going to be, well, the numerator is gender, and gender has degrees of freedom 1. The denominator here is error, and that's got degrees of freedom 40, so that's 1 comma 40. And then our next critical value for party was 3.5. We test and see if that is greater than the table value for 0.05 when you've got degrees of freedom for party was 2. For error, it's still 40. And we'll look that table value up in just a second. And then that last F value was 7. So I'm doing these guys, 2, 3.5, and 7. And test and see if that is greater than the F critical value for 0.05. And then our degrees of freedom are 2 and 40 again. So that's degrees of freedom for the interaction and for error. So now we go to the page 661 in the back of the book and look up these test statistics. So remember, that's the studentized range. So that's page 661 right here. Or I'm sorry, that's critical values for F. on page 661. Our degrees of freedom numerator for the first one was 1, and then the denominator was 20. So we are going to go down to 1 and 20, which is right here, 4.35. So this equals 4.35, and 1 is not greater than 4.35. So I put a question after that, no. So we are not going to reject, we'll retain the null for effect on gender. Now we'll compare the 3.5 to the critical value with degrees of freedom 2 and 40. I'm sorry, I looked at 1 and 20. I need to keep going down. It's 1 and 40. Right here, 4.08. Still not significant. You probably wondered what I was doing, didn't you? Okay, and then we compare against degrees of freedom 2 and 40. Well, that's going to be the value right beside it. So it's 40 and 2. So right there, 3.23. And we get 3.23. And 3.5 is greater than 3.3. Yes, that one is true. So that means we are going to reject the null, because the test statistic is bigger than the critical value. That means the test statistic is in the rejection region. And this last one, that's also 3.23, and that one works as well. 7 here is greater than 3.23, so we're going to reject the null there and say that the effect of the interaction is also statistically significant. So if none of these were greater, then nothing would be significant. So there's lots of different possibilities there. So based on these results, what is the next step? So we're going to compute pairwise comparisons for gender. No, because that was not significant. Are we going to do it for, this should be political party. So pairwise comparisons for party. That one was significant. Okay, so we're going to have to do pairwise, we would have to do pairwise comparisons for that. Simple main effect test for significant interaction. So the interaction was significant, so we would also have to do the main effect test for interaction. So we'd actually have 2 possibilities there that are checked. I think you guys only have 1 in the homework though, one of these that gets checked. So that wraps that problem up.